A remarkable discovery has emerged in the field of astronomy, a one-of-a-kind white dwarf that defies the conventional classifications established in recent years. This extraordinary celestial object, designated WD 0525+526, is an ultra-massive white dwarf, characterized by an outer layer of hydrogen and helium that is astonishingly thin, about 10 billion times less dense than what is typically observed in other white dwarfs. Researchers believe that this unique structure is the result of a merger event that occurred in the past. To understand the significance of this finding, it's essential to grasp what white dwarfs are. These stellar remnants represent the final stage in the life cycle of stars, similar to our Sun, as well as those with a mass up to a few times greater. Unlike more massive stars that can explode in a supernova, white dwarfs lack the necessary mass to undergo such a dramatic end. Instead, after exhausting the hydrogen fuel in their cores, they expand into red giants and subsequently fuse helium. Eventually, they deplete their helium reserves, leading to the expulsion of their outer layers and leaving behind a dense, hot core known as a white dwarf. Typically, white dwarfs have a mass that is about 60% that of the Sun and gradually cool over time. This cooling occurs because their heat is not generated by ongoing nuclear fusion, but rather by the residual heat from the core collapse. However, not all white dwarfs follow this cooling trend. Recent data from the Gaia spacecraft has revealed the existence of hot, older white dwarfs, which retain heat due to a crystallization process occurring within their incredibly dense interiors. Among these intriguing objects, 6 particularly massive white dwarfs caught the attention of astronomers. These stars exhibited carbon in their atmospheres, and their masses were significantly greater than the average white dwarf, suggesting they were formed from merger events. However, WD 0525+526 stands out because it lacks the carbon features typically observed in similar stars. Dr. Snehalata Sahu, a co-lead author from the University of Warwick, explained that the thin layer of hydrogen and helium surrounding this white dwarf is exceptionally sparse, making it about 10 billion times thinner than expected. This raises questions about the processes that led to the removal of the additional hydrogen and helium. Thanks to the advanced ultraviolet capabilities of the Hubble Telescope, researchers were able to detect the presence of carbon in this white dwarf, confirming its origin from a merger event. However, the unique structural characteristics of WD 0525+526 suggest that it may not be undergoing full convection, which would typically allow carbon to escape and be detected in optical observations. Instead, there appears to be a semi-convection occurring beneath the extremely thin hydrogen layer. The exact nature of the object that collided with the original white dwarf to create WD 0525+526 remains uncertain. Some leading simulations propose that it could have been a subgiant star, but many variables are still at play, leaving researchers hesitant to draw definitive conclusions. Dr. Antoine Bedrad, another co-leader of the study, expressed a desire to further investigate the prevalence of carbon white dwarfs among their counterparts and to uncover how many stellar mergers might be hidden within the broader white dwarf population. This research could significantly enhance our understanding of white dwarf binaries and the pathways leading to supernova explosions. The researchers emphasized that their discovery would not have been possible without ultraviolet observations, and they hinted at ongoing analyses involving white dwarfs and the remnants of planetary systems, studies that also rely on ultraviolet data. Currently, the Hubble Telescope is the only instrument capable of such observations, but it is aging and has not been refurbished in 16 years. The next-generation ultraviolet telescope, the Ultraviolet Explorer by NASA, is not expected to launch until at least 2030. Dr. Sahu pointed out the urgency of planning for the next generation of ultraviolet telescopes as Hubble's operational lifespan is nearing its end. This study has been published in the journal Nature Astronomy, and it highlights the importance of continued exploration in this fascinating area of astrophysics. In a recent correction, it was clarified that the hydrogen-helium layer is indeed 10 billion times thinner than previously stated, correcting an earlier miscommunication.